Welcome back to the class on power semiconductor drives. In this lecture, we are going to discuss about the numericals on a DC drive, part 2. In part 1, we have solved the two numericals which are based upon the rectifier, which is there between the AC supply and the DC shunt motor. We are going to solve the two more numericals. The converter is the DC to DC converter, which is placed between the input DC. Load is the DC shunt. A 220 volts 24 amperes 10,000 RPM. Shunt motor has armature resistance of 2 ohm. The motor is controlled by the chopper with a frequency of 500 Hz. The source voltage 230 volts. Calculate the duty ratio for the 1.2 times the rated torque and 500. This is the data which is given in the problem. The rated motor voltage is given at 220 volts. The speed of motor and 1000 RPM is given. The rated current is 24 ampere. Armature resistance is 2 ohm. Source voltage is the 230 volts. Now we are going to find out the at a rated value how much is the back. EB1 equal to source voltage minus IRA. So 220 volts, substitute all the values. Here we have taken this voltage, rated voltage means getting the 172 volts. Now the back EMF at speed 500 RPM. So now we want to find out how much is the back EMF at this speed of a motor. That we have taken is EB2. So N2 by N1 into EB1, all these values. EB1 becomes a 172 and N1 is the rated speed of the motor that is given in the numerical, that is a 1000 RPM. Now where we want to find out the back EMF, that is 500 RPM, that we have to take it as a substitute all the values, we are getting 86. The motor terminal volt speed of a motor is N2, that we have taken as a VA2, that is equal to EB2 plus IA RA. In the numerical it is given that they ask you to find out what is the duty ratio of the chopper. 1 times the rated torque, nothing but this is a shunt motor, so the flux is constant. 1 times means 1.2 times the rated current. So here we have taken 1.2 into 24 into armature resistance plus 86 volts, that is EB2, that gives the VA2, nothing but terminal voltage 143.6 volts. Now this is the output voltage, the input voltage is 230 volts, source voltage is 230 volts. Now you find the output voltage divided by the input voltage, that is the duty cycle. Substitute all the values, 0.624 is the duty cycle of the chopper. So the motor will be running at a 500 RPM, which is taking a current of 1.2 times the rated current. On second numerical, a 220 volts 960 RPM 200 ampere DC motor has armature resistance of 0.02 ohm. If a motor is fed from the chopper, which provides both motoring and braking operation, the source voltage has a 230 volts. Assume the load current is a continuous load current. Calculate the duty ratio of the chopper for motoring operation at a rated torque at 300 R. So we have to calculate what is the duty ratio of a chopper when the motor is running at this speed. So first of all, you are calculating the what is the back EMF, rated voltage and current. So the back EMF EB1 equals 230 minus 200 into 0.02 armature resistance, that gives the 226 volts. So at this value of back EMF, the motor is running at a 960 RPM. Now you have to find out the what is the back EMF at a 350 RPM. That you have to take it as EB1. So EB1 equal to 226 this voltage divided by the speed of a motor, that is 960 RPM into 350, where we have to find out the back EMF, that is 350, that gives the voltage 82.4 volts. So the armature rated voltage VA1 equal to EB1, this voltage plus the voltage drop in armature winding due to the full load current, that is 200 into 0.02, that gives the 86.4 volts. Now the duty ratio equal to this voltage divided by the input voltage of a converter, that is the 230 volts. So we are getting the 0.37 is the duty cycle. Calculate the duty ratio of the chopper for braking operation at a rated torque and 350 RPM. So already we calculated the back EMF at 350 RPM, that is 82.4. So when the same machine is operating in a braking operation, the armature voltage is equal to EB minus IA into RA. Substitute all the values. 82.4 minus 200 into 0.02, that's 78.4 volts. The duty ratio equal to 0.34. In third parameter, we are going to calculate the maximum duty of the chopper is limited to 0.95. The maximum possible current is twice the rated current. Calculate the maximum possible speed of a motor obtained without weakening the field and the power fed to the source. We are finding how much voltage maximum can be given by the chopper, that is 0.95 to 230. We are getting a 218.5 volts. So this voltage plus IARA is nothing but a back EMF. Here the armature current is the twice the rated current. So the rated current is 200. So here we have taken 400 into 0.02. Nearly we are getting 226.5 volts. Maximum permissible speed of a motor. Already we know the how much speed is maintained by the motor at a rated value. So we can find the 226 this voltage divided by the rated voltage into 960 rated speed of a motor, that gives the 962 R. So the power fed to the source, this voltage into current, the maximum voltage is 218.5 into current is 400. So we are nearly getting the 87.4 kilowatt, that much of maximum power that given by the motor to the supply. Nothing but this is the operation what we have taken in a breaking of a DC motor. Thank you very much. If you have any doubt, you can ask me directly, or you can ask in the comment box of my YouTube channel so that I resolve all your doubts.